Hello 172 class, welcome to your first lecture notes. So this very first video we're going to look at the unit circle. So you will hear me refer to the unit circle several times throughout the semester, and a lot, especially here at the very beginning of the semester, until we get down on the different properties of the angle and moving around in the plane on a circle instead of rectangularly like we're used to. And we'll get into all that in more detail later, but I just wanted to go through the basic properties of the unit circle. First being, just recalling from 171, the last class, that the equation of a circle is x minus the x coordinate of the center of the circle squared plus y minus the y coordinate of the center of the circle squared. And that was equal to the radius squared, radius of the circle squared. So, for instance, if this circle, one I have right now, is centered at the origin, if it had been centered, for instance, like let's say over here, and let's say that it was a big circle. Alright, and let's say its center was 3, 4, and the radius was, let's say that that's a radius of 5. Then the equation of that circle would be x minus 3 squared plus y minus 4 squared equals 5 squared, which is 25. Okay, so just a little trip down memory lane. Hopefully you remember those properties of circles. What we're going to do, though, for our unit circle, initially here anyway, is to make this circle centered at the origin. So that would make, in that case, h and k would be 0 and 0. So that would be x minus 0, or just x squared, plus y minus 0, which would be y squared, equals, and because it's a unit circle, by unit we mean the radius is equal to 1. So 1 squared is 1. So this is the equation of the unit circle in standard position. In standard position we mean centered at the origin. Okay, so that's the unit circle. Now, if you think about it, what we're talking about is the radius is 1, and so this particular circle, any point on that circle we could stop at, and that radius is always 1. So there's a lot of different points that we could hit. So this again is 0 on the x-axis, this is 1 on the x-axis. So any point in there, like for instance a half, is a possible value for x in this equation. And if we know what x is, so x is a half, that means that this distance right here is 1/2. We could solve for y by the Pythagorean theorem. So the Pythagorean theorem is going to come up a lot in this course because the formula for a circle basically is the Pythagorean theorem. So I'm going to replace x with 1/2. I'll get 1/2 squared plus y squared equals 1, and I can solve this thing for y. So 1/2 squared is 1/4 plus y squared. I can subtract 1/4 from both sides, and then that would give me y squared is equal to, if I subtract 1/4, I would get 3/4. 1 minus 1/4 is 3/4. And then if I take the square root of both sides, I can get y isolated. Now, if you remember, from not just 171, but math courses in general, previous math courses, when you take a square root to solve for a variable, you should consider plus or minus, meaning it could be positive square root or it could have been the negative square root when we squared it. Now in this case I can see that it's the positive square root, but I won't because y is positive because I'm above the x-axis. But it, without knowing, without being able to see the point in question, when x is a half, there's a point down here also where y would have been the negative square root. So we have to consider plus or minus. Alright, but because of the paper, I can actually see that I'm using the positive square root, I'm going to take away the plus minus. Alright, now remember, this is a big thing in this class. You're going to have to simplify these. 4 is a perfect square, 3 is not. So the 3 stay under the radical. But the 4, because we can take the square root of 4, we do. So we end up with the square root of 3 over 2. So the coordinates of this point right here, where 1/2 is the x-coordinate, is 1/2. And then the square root of 3 over 2. Alright, and we could do that for any point that's within 0 to 1, 0 to -1 for the x-axis. The domain of this thing is -1 to 1. So if we pick any number in there, we could do this process and solve for y and get a point pair. And we'll be doing that, a lot of that kind of stuff this course. Alright, the other thing that's going to be new, and we'll talk about in the next video, is coming up with these angle measures. Alright, we use this Greek letter theta to symbolize an unknown angle a lot of times. So if I know the point on a circle, then I'll find out soon enough that I can also figure out the angle required to start here at the origin and rotate up until I hit that particular point. I can figure out what the angle measure is. So that's another big thing that we'll be doing this course, but all of it's going to start off with this idea of the unit circle, and that's just a circle, radius 1, centered at the origin for simplicity's sake.